Assalamualaikum and hi, we are from Group 7, we'll present our assignment 1. In this group, we have 4 members, which are Hana, Wani, Amir, and Shamini. Next, in this video, we have 4 sections which are question, solve question using Jacobi method and Gauss-Seidel method by handwriting, solve question using Jacobi method and Gauss-Seidel method by programming software, and the last one is comparison between Gauss-Seidel method and Jacobi method. Section 1, question. Here, we have 3 equations for this question. For the equation 1, we have 10x1 plus 2x2 minus x3 equal to 7. For the equation 2, we have x1 plus 8x2 plus 3x3 equal to negative 4. And for the last equation is negative 2x1 minus x2 plus 10x3 equal to 9. Then we move to the next section, which is solve question using Jacobi method and Gauss-Seidel method by handwriting. Using Jacobi method. First step, we have to rearrange the equation. From the equation 1, we have to get the x1. From the equation 2, we have to get the x2, and same here for the equation 3, we have to get the x3. Second step is find the initial value of x. In this case, we use the initial value of x1, 0, x2, 0, and x3 also 0. Then, use the initial value of x to find first iteration. We got first iteration of x1 0.7000, x2 negative 0.5000, and x3 0.9000. The fourth step is use the value of x in iteration 1 to find second iteration. Then we got the second iteration, which are x1 is 0.8900, x2 negative 0.9250, and x3 is 0.9900. Then we use the values of x in iteration 2 to find the third iteration. We use the same process like before to get the new x1, x2, and x3. Then we got the third iteration of x, which are x1 is 0.9840, x2 negative 0.9825, and x3 is 0.9855. Then we use the values of x in iteration 3 to find the fourth iteration. Then we got the new value of x1, x2, and x3. The last step is we repeat the step until the iteration convergence. Here we can say that the iterative process converges after 8 iterations. Next, we are going to solve using Gauss-Seidel method.
For step 1, we need to rearrange the equation. For example, from equation 1, we get x1 equal to 7 minus 2x2 plus x3 over 10. From equation 2, we get x2 equal to negative 4 minus x1 minus 3x3 over 8. And from equation 3, we get x3 equal to 9 plus 2x1 plus x2 over 10. Step 2, our initial approximation for x1, x2, x3 is equal to 0. Step 3, to find the value of x1, we need to use our initial approximation x2 and x3. By that, we get x1 equal to 0.7. To solve x2, we need to substitute the value of x1, which is 0.7, into the equation 2. So, for x2, we get negative 0.5875. For x3, we need to solve 9 plus 2 multiplied with 0.7, which means the value of x1, and minus with x2, 0.5875, and divide all the thing with 10. By that, we get x3 equal to 0.9813. So, our first iteration is 0.7, negative 0.5875, and for x3 we get 0.9813. Step 4. We need to substitute the updated value of first iteration into the equation 1, 2, and 3 to get the second iteration. So, for x1 we get 0.9156, x2 negative 0.9824, and lastly for x3 we get 0.9859. Step 5. To get the iteration, repeat step 4. So, we need to substitute the new value of second iteration into the equation 1, 2, and 3. So, our third iteration is 0.9950, negative 0.9937, and lastly for x3, 0.9996. To find fourth iteration, we still use the same method, which is repeat the step 5. But please don't forget to substitute the new value of x1, x2, and x3 from the third iteration. So our fourth iteration, we get 0.9987, negative 0.9997, and lastly for x3 we get 0.9998. Step 7. Repeat all the steps until the iteration become convergence. As you can see, the table show at iteration 6 we get x1 equal to 1, x2 equal to negative 1, and x3 we get 1. So, we can conclude that the solution start to converge in iteration 6 in the Gauss-Seidel method.
Section 3. Solve equation using Jacobi method and Gauss-Seidel method by programming software. Using Jacobi method.
First, let us see the coding for the Jacobi method in Mathematica. In first row, there is stated JAC, which represents Jacobi, and then in bracket there is A. A represents the coefficient of matrix, B represents the vector of coefficient, and X star represents the initial guess. Below that we have K, which represents the iterations. In bracket beside the while, you can enter any iterations, any number of iterations you want. For example, I myself stated 100 there. Second of all, this is the following coding for the Jacobi method in Mathematica. Just now, previously, we have one coding and this is the second coding. Through this coding, we have our question, which is 10x1 plus 2x2 minus x3 equals to 7, x1 plus x2, 8x2 plus 3x3 equals to negative 4, negative 2x1 minus x2 plus 10x3 equals to 9. So this is our question and we are going to turn it into the Jacobi method in Mathematica. Coding type. A, as I said, represents the coefficient of matrix. So our coefficient of matrix is 10, 2, -1, 1, 8, 3, -1, -2, -1, and 10. And B represents the vector of coefficients, so our coefficient is 7, -4, and 9. X star, as I said, it represents the initial guess, so our initial guess is 0, 0, and 0. Okay, last not but least, the JAC check and AB X start we have to state there so that the following coding will complete, so that we will get the iteration. As I run the iteration, the result for Jacobi method in Mathematica is up to 100. I just sort it out up to iteration 23 because the iteration here stopped and converged at 11th. So basically the result from the Jacobi method manually and in Mathematica is slightly different, where the manual iteration stops at 8th and in Mathematica it stops at 11th. This is because the difference in implementation details and the numerical completion, they may converge a slightly different iteration, but still the answer is the same.
Next, we are going to solve the equation using Gauss-Seidel method.
Hello guys, so this is Gauss-Seidel method, the code for Gauss-Seidel method. So here I'm opening the new node, so I can copy the code that I prepared for you and paste it on the new node. So next, what I'm about to show you is the question that we use as a sample. We teach you how to use this kind of question into the we fill into the Gauss-Seidel code, and then we change the questions into the matrix form, but in this code form. As you can see now, the value of A will be the matrices, which is 3 by 3 times 3, and then B will be the right hand side, which is 3 times 1. So as I said, that you just follow all the code I give to you now, and don't forget to don't forget to type the Gauss-Seidel A, B, and start before you run the code. And here I just have to press Shift and Enter at the same time so I can run the code. And here we see the results. And there you go, the results. So the iterations will be like 100 iterations. Just for you to know, we can change the amount of iterations that we want. So here I'm going to show you how. So we just need to change the value of 100 here into 20 or any amount you want, any amount of iterations that you want. So I choose 20, so you can see now the result will be 20 iterations. And now the convergence will be at the iteration 8.
The last section is comparison between Jacobi method and Gauss-Seidel method.
Hi everyone, this is the part of the comparison between Jacobi method and Gauss-Seidel method. The first comparison is, in Jacobi method, each variable in the system is updated simultaneously using the values of the previous iteration. But in Gauss-Seidel methods, variables are updated one by one, and the updated value of each variable is immediately used in subsequent calculations. Second comparison is, the Jacobi method converges when the spectral radius of the iteration matrix is less than 1. It is granted to converge for diagonally dominant or symmetrically positive definite system. The Gauss-Seidel method has a faster converge than the Jacobi method, where it converges for diagonally dominant, symmetric positive definite, or strictly diagonal dominant systems. The third comparison is, the Jacobi method is generally slower compared to the Gauss-Seidel method because it updates all variables simultaneously. But the Gauss-Seidel can converge faster since it utilizes the most recent updates values during the iterations. So, the summary of this video is, based on the comparisons, the Gauss-Seidel method generally converges faster compared to the Jacobi method.
That is all from us. Thank you for watching.